to be doing on paper, and also a bit of wiring that you're going to have to do on the E5AK T. Okay, so this is the handout. We have 3 pages where I'm going to show you scenarios. Let's say in this case here, this page here, I'm going to tell you that we want to heat only and heat on off. Okay, I'm going to flip this around eventually. I'm going to show you output 1, output 2, what they're used for. We have a second page. I'll give you a second scenario as an example. We're going to heat, but proportionally. Then we have a third example or a third diagram where we're going to cool only. And then we have the last one where I'm going to show you how we can wire it so that we can heat and cool. Okay, so this is basically the layout of most of the wiring that's already pre-wired on this board. The only thing you're going to have to do is, depending on whether you're using output 1 or output 2, and output 1 will be used for heating and cooling, okay? Not at the same time. Okay? This controller can only do one thing or use one output for one task at any given time. So if I program it output 1 for cooling, it's for cooling. If I program output 1 for heating, it's for heating. Now, I will say that for output 1, right over here, which is terminal 7 and 8, that is only on off. So definitely will not be used for proportional heating. Okay, on off, if we program it for cool, we can wire the fan. If we program it for heat, we're going to use the SSR, solid state relay. Okay, heating with the SSR. So let's look at this first scenario. Okay, if I wanted to cool, all I have to do wiring wise, not programming, but just wiring wise, is take my output 7 here. So let me just backtrack a little bit. We have a power supply here, which we mentioned already. We have 24 volts going into pin 10 to power up the unit, 9 and 10. We discussed that yesterday as well. And here you have a relay for 7 and 8. So for inputting 24 volts to 8, just like a regular relay, when cooling is desired, so when the temperature that you want is less than what you're asking, than what it is, the contact closes. And look at this wire here. It's going to 7 right now. But we have this blue wire here going to the fan, which we're going to use for cooling. Okay, you don't move this wire. This wire stays on 8. So if I wanted to cool, what would I have to do? I would have to take this wire that's on 7 and bring it to 8. That's it. That's all the wiring you're going to have to do to cool. Bring this wire from here to here, and then the rest is programming. Okay? Now, scenario 2. But I was using paint here. Can't do that. Okay, scenario 2. Actually, I could undo. So scenario 2 is basically the second scenario. Let's say the second scenario here is I want to heat. Well, I can only heat using output 1 using the SSR. So what's not shown here is that there is a wire leaving 7, which is going to go to A1 of the SSR, which is already pre-wired. You do not have to pass this wire. There's nothing for you to do. All you're going to have to do if you are heating using output 1 is take the wire we just talked about, this wire here, and instead of having it on 8, which is used for cooling, you're going to put it on 7. If it goes to 7 and you set the thermostat to 25 degrees and it's presently 21 degrees, so 21 degrees is your present value or process value, and 25 is your set point or your desired temperature. Well, if you want 25, guess what's going to happen? The contact between 7 and 8 will close. Current will flow to A1, activate the SSR. And if you look at the top of the SSR, there's already a line. Okay. If you look at the bottom, this is the output. If you activate A1 of the SSR, well, the output will go to pin 4 and supply power to 4. Now, what the only thing that you have to do here is take this wire here, which is going to the light, which is our heat source, and make sure that it's wired to 4 and not 3. That's it. If the wire's already on 4, there's nothing for you to do. If the wire was on 3, and I'll explain why it was on 3 after. If it's on 3, you put it on 4. That's it. That is scenario 2. Now, scenario 3 would be if I wanted to heat using the proportional relay. So if I want to heat using the proportional relay, I'm going to use output 2. Output 2 can only be used for heat and only proportional heating. What does that mean? It means PID. So with the E5AK T, if you go to expansion mode and go to control and you go to PID, it means that you are controlling using proportional. Okay. Whereas here, this whole on off is just basically that, on off. It's a contact. Closes, opens, that's it. So there is a wire, or there are 2 wires leaving pins 5 and 6, which are linked to output 2, which we discussed yesterday. And this 5 and 6 here, if we follow them, okay, leaving 5 and 6, follow, goes to 5 and 6 here, there is nothing you have to wire here. There is nothing you have to wire. This is all pre-wired. But where is it going? It's going to the bottom of the proportional relay, where it accepts a 0 to 10 volt signal. Now the output, as it says here, is a 0 to 10 volt signal depending on the error. So as I said before, if it's 21 degrees in your house and you set it to 25, you have an error of 4 degrees, which is considerable percentage-wise. So you're going to want to heat as much as possible. What that means is that the proportional relay, which is output 2, is going to output a 10 volt signal, the max. When this proportional relay gets a 10 volt signal, the output, which is right here, this is the input, this is the output, which is going to pin 3, will output 120 volts in this case here. So if it's outputting 120 volts, if we first of all, what we're going to have to do is take this wire, which is on 4, let's say, or if it was on 4, and we're going to put it to 3. If we put it to 3, they're joined together. So now if we're using the proportional relay, the output, 120 volts, as I said, is going through this wire, and the light is on 100%, okay? As the temperature here starts to go up, 22, 23 degrees, 24 degrees. So at 24 degrees, we have an error of 1 degree. So you don't want to overshoot. Fine control means that you want to vary the output so that you don't overshoot or undershoot. So what's going to happen is, and I'm just going to give you an example here, output 2 will be, let's say, 5 volts. If output 2, going through terminals 5 and 6, send 5 volts to my proportional relay, and generally speaking, what do you think the output will be in terms of voltage going to my light? Approximately half as well. Let's say 60 volts. Well, if I'm supplying 60 volts to my light bulb, what's going to happen? It's going to be half as bright. Okay, so it's going to be dimmer. Okay, again, the light bulb here, yes, it does provide heat, but it represents heating because we can actually see how much of it is on or how intense the light is, and that's basically the output. With a heater, you can't do that. Okay, the metal gets hot, that stays hot. This here, we can see what the output is. So if we use output 2 to heat, it means we have to go into programming, go to output 2, select heating, and once we do, you've linked terminals 5 and 6 to the proportional relay. When the temperature you want is greater than what you have, automatically it activates the output. Depending on the error, the voltage going to your light bulb will vary. Okay, so that is scenario 3. So scenario 1 was cooling on off with output 1. Scenario 2 was heating on off using output 1 via the SSR. And the third one we just discussed is basically using output 2 to heat proportionally. And now, if we merge the two together, if I want to heat and cool, so if I want to heat and cool, I have to use output 1 and output 2. So if I'm using heat and cool, I have no choice but to use output 1 for cooling. And what's left? Output 2 for heating. So it's kind of like merging the first example I gave you with the third. So what do I have to do in terms of wiring? Again, the only wiring you have to do is here and here. The rest of it is configuring the E5AK T. So if I wanted to cool with output 1, it means that this wire, which is on 7 now, would have to go to 8. Why 8? Because I have a wire on 8 going to my fan, which is for cooling. If I wanted to heat using output 2, well, look, these two wires are going to my proportional relay, if you follow the crayon here. So the output of this proportional relay is right here, and it's going to pin 3. So what I have to do in order for it to heat is make sure that the wire going to the light bulb here is going to 3 to join the wire coming from the proportional relay. Okay, it's as simple as that.
So